This question I have taken from CBSE sample paper. I have found that most of the students are doing this question wrongly because there is a concept in this question which is not known to the students correctly. First, I will clear that concept. After that, I will do the question. Suppose A is a set containing element 1, 2, 3, 4 and 5. Suppose R is a set on A defined by ordered pairs 1, 2, 1, 3, 1, 4 and 1, 5. And I want to check that the relation R is a transitive relation or not. To understand the concept of transitive relation, a relation is said to be a transitive relation if this condition is satisfied. And the condition is, suppose AB belongs to R and BC also belong to R. Then AC must belong to R. I mean, whenever AB and BC are belonging to R, then AC must belong to R. This should be always true for every two ordered pairs whenever this element and this element are same. For this relation, if I take one ordered pair as 1, 2, there is no any ordered pair whose first element is 2. Therefore, 1, 2 cannot combine with any other ordered pair. Similarly, 1, 3 also cannot combine with any other ordered pair. Similarly, 1, 4 and 1, 5. For checking this thing, that the condition of transitive relation is being satisfied or not, we require two such ordered pairs for which second element of 1 and first element of second should be same. And because this is not satisfied for any two ordered pairs in R, therefore we can't apply the condition of transitive relation on R. In such a situation, at this point, most of the students get confused that if this type of situation happens, in that case, R will be taken as a transitive relation or it will not be taken as a transitive relation. Let me make it absolutely clear to you that in such a situation, R will be taken as a transitive relation. The condition of transitive relation is neither being satisfied on R nor being dissatisfied on R, because condition of transitive relation is not applicable on any two ordered pairs in R. But remember, we give preference to this thing that because condition of transitive relation is not being dissatisfied, hence R will be taken as a transitive relation. One more very simple example of this is, let us take the example of empty set. We know that empty set is also a relation on A, because you must be knowing that as the set A contains 5 elements, number of ordered pairs in A cross A will be having 25 elements. And because it is having 25 elements, number of subsets of A cross A will be 2 to the power 25. And every subset of A cross A is called a relation. Out of 2 to the power 25 subsets, this is also one of the subset of A cross A. Hence, this is also a relation on A, because it is a subset of A cross A. Set A cross A is also a relation on A because every set is subset of itself. In 2 to the power 25 relations, we have counted this also and A cross A also. And because this is also a subset of A cross A, hence R is also a relation. I can't apply the condition of transitive relation on this set. In such a situation, it will be called a transitive relation or it will not be called a transitive relation. I will say it will be called a transitive relation. The reason being, because the condition of transitive relation is not being dissatisfied, hence this set will be called a transitive relation. The students must be very much clear about it. In this question, it is told to us that a relation R in the set A equal to this is defined as R equal to this. Which of the following ordered pair in R shall be removed to make it an equivalence relation in A? It is clear that for a relation to be equivalence relation, it should be reflexive, symmetric and transitive all. And for the relation to be reflexive, keeping these elements in mind, 1 1, 2 2, 3 3, all these three ordered pairs must belong to R for the relation to be reflexive, and because these three are in R, therefore R will be called a reflexive relation. For the relation to be symmetric, we know that if AB belongs to R, then BA must belong to R. In every case, whenever AB belongs to R, BA must belong to R. Then only the relation will be called a symmetric relation. But in R, this ordered pair 1 2 is there, and the opposite of 1 2 is 2 1, which is not in R. Hence, R is not a symmetric relation. But if I remove the ordered pair 1 2, that is, after removing 1 2, R will be a symmetric relation because opposite of 1 1 is same 1 1, which is in R. Similarly, opposite of 2 2 and 3 3 are in R. Therefore, after removing 1 2, R will be a symmetric relation. Let me make this point also again clear, that suppose let us take the case of empty set. Empty set will be called a symmetric relation or it will not be called a symmetric relation. Remember that empty set will be called a symmetric relation because the condition of symmetric relation is whenever AB belongs to R, then BA must belong to R. But there is no any ordered pair in it. In such a situation, we can't apply the condition of symmetric relation on this set, and because we are not able to apply the condition of symmetric relation on this set, hence it will be called a symmetric relation on the basis of this opinion that because the condition of symmetric relation is not being dissatisfied, hence we will say empty set is a symmetric relation. And after removing 1 2, R has become a symmetric relation. And now what about transitive relation? It is clear that on this set, for checking the condition of transitive relation, there are no two ordered pairs for which second element of one ordered pair and first element of second ordered pair becomes same. That is, the condition of transitive relation is not applicable on any two ordered pairs of this set. Hence, it will be called a transitive relation on the basis of this opinion that because the condition of transitive relation is not being dissatisfied, hence this is a transitive relation. That is, I can say after removing 1 2, the relation I have got this thing is a reflexive, symmetric and transitive all. Remember that empty set is not a reflexive relation, because for the relation to be reflexive, 1 1 2 2 3 3, all the three must be present, then only the relation will be a reflexive relation. More than these, any other ordered pair is allowed to come. For relation to be reflexive, the main condition is only these three ordered pairs must come. For any other ordered pair, there is no condition. And again, this question I have taken from CBSE sample paper. In this question, it is given that consider the non-empty set of all human beings in a town at a particular time, and a relation R defined as XII if and only if X is wife of Y, then R is. First thing you must be knowing that XRY and XY belongs to R is same thing. Suppose H is the non-empty set of all the human beings in a town. The elements of this set are all the human beings of the town. We can easily find the set H cross H. The ordered pair XY of the set H cross H will belong to R if X is wife of Y is given in the question. That is, in every ordered pair of R, first will be female and second will be always male. The relation R cannot be reflexive relation because nobody can be wife of himself. Second is symmetric relation. If XY is belonging to R, then YX belongs to R is never true, because if X is wife of Y, Y will not be wife of X because Y is male and X is female. And now the similar thing which I explained in the previous question about transitive relation. Suppose in R the ordered pair XY is present. It means X is wife of Y, but there will not be any other ordered pair which can combine with XY, because for any other ordered pair to combine with XY, Y should be as a first element, and because Y is a male, therefore Y can never come in the first place. Hence XY cannot combine with any other ordered pair. To check the condition of satisfaction of transitive relation, means there is no ordered pair in R which can combine with XY. That is, in R no two ordered pairs can combine. That is, I can say the condition of transitive relation is not applicable on any two ordered pairs. As I explained previously, in such a situation, R will be called a transitive relation. The reason being, because the condition of transitive relation is not being dissatisfied, hence we will say the relation R is transitive. This is one more question I have taken from CBSE sample paper. In this question, it is told to us that we have to find the number of equivalence relations on the set 1 to 3 containing 1 2 and 2 1. For clear understanding, I will discuss this question in complete detail. Suppose the name of the set is A. It is clear that A cross A will be 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2 and 3 3. Obviously, if there are 3 elements in A, number of elements in A cross A will be 3 square, that is 9. And because there are 9 elements in A cross A, hence number of subsets will be 2 to the power 9. And we know that every subset of A cross A is called a relation. Hence 2 to the power 9 relations are possible on the set A. But presently we are discussing the case of number of equivalence relation. Obviously, if a relation is equivalence, say that relation is R, then 1 1, 2 2, 3 3 must belong to R. Even if 1 is absent, it will not remain reflexive. Therefore, all the 3 must be present in R. And this is also given that 1 2 and 2 1 are also belonging to R. The only ordered pairs to be discussed are this, this and this. If I don't include any of them in R and I complete it here only, it will be a equivalence relation because it is reflexive. Clearly, just now I told it is symmetric. Yes, it is also symmetric because if AB is belonging to R, then BA is also belonging to R. While checking about transitive relation, you should never waste time in using those ordered pairs in which first and second elements are same, because if you are using such a ordered pair in which first and second elements are same, suppose you take AA belongs to R and suppose AC is also belonging to R, then the condition of transitive relation will be automatically satisfied because these two are same, and the condition of transitive relation says that AC must belong to R. This is already there. Therefore, you should never waste time in using those ordered pairs in which first and second elements are same. And after ignoring these 3 ordered pairs, we can apply condition of transitive relation only on these 2 ordered pairs. And 1 2 is belonging to R, 2 1 is belonging to R, then the condition of transitive relation says that 1 1 must belong to R and it is belonging to R. And if I take 2 1 first and 1 2 afterwards, then the result says that 2 2 must belong to R and 2 2 is also belonging to R. Therefore, condition of transitive relation is being satisfied wherever it is applicable. Hence, this is one of the equivalence relation defined on A. But we have to find total number of equivalence relations. And now let us take the other cases one by one. Note that we had to discuss about only 1 3, 2 3, 3 1 and 3 2. And second case is, suppose I include the ordered pair 1 3 in it. If 1 3 is included, then 3 1 will have to be included for the relation to remain a symmetric relation. And it is also clear here that again in this case also, wherever the condition of transitive relation is applicable, that is being satisfied. For example, on these two, condition of transitive relation is not applicable, but on these two the condition of transitive relation is applicable and it is being satisfied because the result says that 1 1 should belong to R. And if I keep 3 1 first and 1 3 afterwards, then also the condition of transitive relation will be satisfied. Hence we have found that after including 1 3 and 3 1, the relation R is still a equivalence relation. And now I discuss the case when 1 3 and 3 1 will not be included, but 2 3 and 3 2 are included. By including these two, the relation has not remained a transitive relation. Note that if 2 3 is included, 3 2 will have to be included because otherwise the relation will not remain symmetric. But the condition of transitive relation is applicable on these two ordered pairs. 1 2 and 2 3 are belonging to R. But according to the condition of transitive relation, after combining these two, the result 1 3 should belong to R, but 1 3 is not belonging to R. Therefore, this relation is not transitive. Hence, if 2 3 3 2 are included, 1 3 3 1 will have to include. And now this is same as A cross A, and A cross A itself is always a equivalence relation, you must be knowing. And now it is not required to check about the satisfaction of transitive relation, because if A is any set, then the relation A cross A. Note that A cross A is also a relation defined on A, and this relation is called universal relation. And universal relation is always a equivalence relation. Hence we have got three possible equivalence relations in which 1 2 and 2 1 are present. One case when nothing of these four was included. Second case when 1 3 and 3 1 were included. And third case, the whole, that is A cross A. Hence the answer of this question is D. This is the next question I have taken from CBSE sample papers. In this question, it is asked that find the maximum number of equivalence relations on the set containing the elements 1 2 3. One way of doing this question is make all possible equivalence relations, but that is not short, that is time taking, but it is a objective question. For objective question, I will just have to say, remember this result, that if there are 3 elements in a set, number of equivalence relations defined on that set is 5. But you will say, what about if there are 4 elements in the set A? I will say if there are 4 elements in the set A, number of equivalence relations will be 15, which is too much lengthy. If you try to find all possible equivalence relations in the case of 4 elements, hence that question cannot come in board level. Still, for those students who wants to increase their knowledge of finding the number of equivalence relations in the case of set contains 4 elements or 5 elements or 6 elements, again I am telling you this is just for knowledge, not for board. For those students, I will say to find the number of equivalence relations, you will have to remember this table, and way of making table I'm going to tell you. Start writing 1 and 1 again, and now add these two, you get 2, and the same to write here again, and now add these two, you get 3, add these two, you get 5, and same 5 write here, add these two, you will get 7 here, add 7 and 3, you will get 10 here, add 10 and 5, you will get 15, and again write 15, same here, add these two, you will get 20, add these two, you will get 27, add these two, you will get 37, add these two, you will get 52, and again write 52, and in this way you can go on for any number of rows. This number denotes the number of equivalence relations if the set A contains one element. This is the number of equivalence relations 3 elements, that is 5. This is the number of equivalence relations when the set A contains 4 elements. This is the number of equivalence relations when the set A contains 5 elements. Obviously, some students will ask, what about the number of equivalence relations if the set A contains n elements? And to those students, I will say that is higher mathematics. If you want, I will make a video on this thing also. Actually, in short, I can say you will have to understand the concept of Bell number to find the number of equivalence relations when the set A contains n elements. This is not in the syllabus of even JEE Mains or JEE Advanced. Still, if you want, you can write in comment about your request of making the video on detail of Bell number. This is the next question I have taken from CBSE sample papers. This is, if the set A contains 5 elements and the set B contains 6 elements, then the number of 1-1 and onto mapping from A to B is. If the concept of onto mapping is clear to you, then you must be knowing that for onto mapping, on every element of codomain, one or more than one arrow is reaching. That is, there should not be any element in codomain on which no arrow is reaching. If there is a element in codomain on which no arrow is reaching, then the function will not be onto. You must be knowing about it. And the condition for the function to be 1-1 is on every element of codomain at the most one arrow should reach. If there is a element in codomain on which more than one arrow reaches, then the function will not be 1 1. If you are clear about 1 1 on 2, then it is not difficult to understand. Hence, if codomain contains more number of elements than domain, then onto function is not possible. As in this case, set A contains the element A1, A2, A3, A4 and A5. The set B contains the element B1, B2, B3, B4, B5 and B6. For the function to be onto on every element of B, at least one arrow should reach. When only 5 arrows are coming out, 5 arrows cannot cover all the 6 places. That is why I told that whenever codomain contains more number of elements than domain, then onto function is not possible. And if codomain contains less number of elements than domain, in that case 1 1 function is not possible, because for the function to be 1 1 on every element of codomain, at the most one arrow should reach. If there is a element in B on which more than one arrow reaches, then the function will not be 1 1. And in the case if A contains more number of elements than B, that is, as here 5 elements are here and this contains 4 elements, 5 arrows when they will come out and they have to reach at these 4 places, there will be at least one element on which more than one arrow will reach. Hence the function will not be 1 1. And if the 2 contains equal number of elements, then the function which will be 1 1, that will automatically become onto, and the function which is onto, that will automatically become 1 1. But all these things are true when I am dealing with the sets having finite number of elements. But if the sets contain infinite number of elements, but as in this case, A is containing 5 elements, B is containing 6 elements, that is 5 arrows have to come out and they have to reach at these elements, cannot cover all the 6 elements. Hence onto function is not possible. And because I want the function which is both 1 1 and onto, hence number of 1 1 onto functions is 0. And if A contains more number of elements than B, in that case number of 1 1 function will be 0. And if the 2 contains equal number of elements, the function which is 1 1, that is onto also, and the function which is onto, that is 1 1 also. But all these things are true when I am dealing with the sets having finite number of elements. In this question, it is told to us that if the set A contains the element 1, 2, 3, 4 up to n, and the set B contains 2 elements AB, then the number of surjections from A into B is. You must be knowing that the meaning of the word surjection means onto function. Here the set A is containing n elements and the set B is containing only 2 elements A and B. You must be knowing that if the set P contains m elements and the set Q contains n elements, then the number of functions is n to the power m. For clarity, I am telling you, if the elements are P1, P2, P3 up to Pm, and the elements here are Q1, Q2, Q3 up to Qn, the arrow which will come out from P1 that can go to any of the n elements. Therefore, first arrow can go in n ways, and again second arrow again can go in n ways, n in this way, n for the last elements. Therefore, n to the power m will become the number of functions. You must have studied it. And because there are two elements in it and n elements in this, therefore total number of functions are 2 to the power n. In all the functions, the n arrows coming out from here will be going to either A or B. Some arrows will go to A, some arrows will go to B. But there is one case in which all the arrows will go to A and no any arrow goes to B. Or one more case when all the arrows coming out from A goes to B and no any arrow goes to A. The first case, when all the arrows are going to A, in that case that is a function, but that is not onto function because this element is not being covered by any arrow. And if all the arrows are going to B, that is also not onto because this element is not being covered. In all other functions, some arrows will go to A, some arrows will go to B. That is, all other functions will be onto functions. Therefore, total number of onto functions in this case, when the A contains n elements, B contains 2 elements, number of onto functions will be 2 to the power n minus 2. Rejecting those two cases, when all the arrows will go to A, one case, when all the arrows go to B, that is the second case. Therefore, B becomes the correct choice.